to prepare for SSC JE RRB and different type of technical exams on the basis of mechanical engineering. Previous year question is very important. So I discussed the previous year question of the total books of the youth competition mechanical engineering books. Okay. It is the third lecture of the fluid mechanics. So डेली प्रैक्टिस करने के लिए चैनल को सब्सक्राइब और नोटिफिकेशन ऑन करके रखना. Okay, let's start the question answer. There is also given the explanation of the every questions. Okay, first question is which of the following is the dimensions less for dimensional formula for the kinematic. Okay, we know kinematic viscosity nu equal to dynamic viscosity by density. Okay, dynamic viscosity by density, or we also know that the unit of the kinematic viscosity is मीटर स्क्वायर पर सेकेंड. यहाँ से भी कर सकते हो. देयर इज द मीटर स्क्वायर यानी L2 और T2 - 1 L की पावर 2 T2 - 1. ऑप्शन ए इज द करेक्ट. यहाँ से भी कर सकते हो. डायनामिक विस्कोसिटी इज m T-1 and density is m L -3. सो एम कट जाएगा. एल से एक एल कट जाएगा. ऑल्सो यहाँ से भी आएगा L2 T2 - 1. फिर भी एक्सप्लेनेशन देख लेते हैं. Here is the explanation of this question. Kinematic viscosity equal to dynamic viscosity by density m0 LT2 or T2 - 1. Next question. The capillary rise at 20 degrees centigrade in the clean glass tube of 1 mm diameter containing water is. Capillary rise equal to 4 sigma cos theta by rho GD. If you put there is the explanation, because small skin here, so it is not possible to calculate. You remember this data. Surface tension equal to 0.0725 Newton per meter, because without it, this data you cannot calculate the capillary rise or the fall if not given the surface tension of the water. Okay, if you calculate this, you get that 29.56 mm. Next question. If you know the answer, please comment the answer in the chat box. Next question. Viscosity has the following dimensions. What is the dimension of the viscosity? Viscosity means dynamic viscosity. ml -1 T -1. Option D is the right. ml -1 T -1. This book is very good for previous year questions practice. Next question. Which is the fluid whose viscosity does not change with the rate of deformation? A. Ideal fluid. B. Real fluid. C. Newtonian fluid. D. Non-Newtonian fluid. Please answer in the chat box. Viscosity does not change with the rate of deformation. In non-Newtonian fluid, because Newtonian fluid is the shear stress is directly proportional to deformation rate of shear strain d theta by dt. Sorry, Newtonian fluid, because the explanation is given here. Does not change. At a given temperature, viscosity of the Newtonian fluid is the constant and does not change with the rate of the shear deformation. Okay. There is the kinematic viscosity is constant for the Newtonian fluid. Next question: the dynamic viscosity of the most of the gases with rise in the gas's temperature. Please say me what is the reason of the dynamic viscosity in case of the gases. For the gases, causes of the viscosity is due to intermolecular collision, or randomness of the molecules of gases. So, if we increase the temperature, then increase the molecular collision, so increase the dynamic viscosity. Here the explanation, you can see explanation is the dynamic viscosity of most of the gases with the rise in the gas temperature increase as the root T, and the kinematic viscosity is 3 root T. Okay. The kinetic theory gases predict the viscosity of the gases to proportional to the square root of the temperature, and dynamic viscosity is cube root of temperature. The prediction is confirmed by the practical observations by deviations for the different gases need to be accounted for by encrafting the some correction factor. This viscosity of the gases is expressed as a function of the temperature by the Sutherland correction from the US standard atmospheric gas. Next question. Pseudoplastic is a fluid for which a dynamic viscosity decreases as the rate of shear increases. B. Newton's law of viscosity holds good. C. Dynamic viscosity increase as the rate of shear increase. D. Dynamic viscosity increases with the time for the which shearing force are applied. A pseudoplastic fluid is shear thinning fluid. So dynamic viscosity each decreases as the rate of the shear increases. Here is the explanation. Fluid is which the apparent viscosity increases with the increasing the deformation rate called the pseudoplastic. Um, Most non-Newtonian fluid falls into this group. Example: polymer solution, colloidal suspensions, milk, blood, etc. Next question: the viscosity of fluid varies with A. Temperature, B. Volume, C. Mass, D. Density. A. Temperature. Which of resistance to flow of the fluid according to the Newton's law of viscosity directly proportional to dy by dy. Dynamic viscosity or the absolute viscosity is mu. The viscosity or the dynamic viscosity varies with the temperature, or for liquid viscosity decrease with the increase in temperature, and the gaseous viscosity increase with the increase in temperature. Viscosity of liquid is mainly depends upon the cohesiveness, and if the increases temperature, cohesion decrease, so liquid viscosity decreases. Which one of the following the bulk modulus K of the fluid? Bulk modulus is dP by dV by V. So option C is the correct. Don't be confused between the bulk modulus and the compressibility. Next question, surface tension is due to A. Viscous force, B. Cohesion, C. Adhesion, D. The difference between the cohesion and adhesion. Due to cohesion. Is the explanation. If you new in my channel, please subscribe. Surface tension. What is the surface tension? Surface tension is the defined the tensile force per unit length at the interference of the two immiscible fluid. The main causes of the surface tension is cohesion forces between the molecule of the fluid. Question number 60. The mercury does not wear the glass due to its property known as the cohesion. Sorry. Mercury does not wear the glass due to its property is the surface tension, due to surface tension, and the causes of the surface tension is a cohesion. And the mercury does not wear the glass due to its property known as the surface tension. The surface tension of the property is liquid. Its expression. Next question, which of the following meters is not associated with the viscosity? A. Redwood, B. Shebolt, C. Englar, D. Orsted, B. Sebolt. So, sorry, Orsted. So explanation is given here. An Orsted meter is not associated with the viscosity. An Orsted meter is used to the volumetric analysis of the flow gases. An Orsted meter gases analyzer is a species of the laboratory equipment for its oxygen, carbon monoxide, redwood viscometer. You determines the viscosity. Large viscometer is used to the measuring the viscosity of the lubricating oils. Next question. Viscosity is measure of the resistance to a flow. So check कर लेते हैं. Viscosity is the property of a fluid which the determines its resistance to sharing the stresses of the measuring of the resistance to flow. Viscosity of fluid change between the fluid layers according to the Newton's law of viscosity. Kinematic viscosity also given. Next question. Which one of the following is defined as the force per unit length? Force per unit length is called the surface tension. There is the explanation. It is the property of a liquid enables to the resist the tensile stresses is denoted by the sigma. SI unit is Newton per meter or the joule per meter square. It is due to the cohesion force among the molecules of the liquid. Fluid is a substance which offers no resistance to change of. C. Safe. Let's check the answer is correct or wrong. Yes, C is the answer. The properties of the fluid materials. Uh, it has the property of the fluidity. It does not always do the change its shape. Viscosity is not zero, but an ideal condition. Liquid and the gases are the fluid materials. In the real, there is no ideal fluid. Real में Pascal second is the unit of Pascal second is the unit of kind. It is the dynamic viscosity unit. Meter per second. in the Pascal second. Let's check it. Yes, dynamic viscosity is Newton second per meter square. It's called the Pascal second also. Next question 66. The desirable properties of any particles fluid. Desirable properties should be viscous, should possess the surface tension, should be compressible. Practical fluid is also a viscous fluid and the surface tension is having and compressible. Should be compressible. हो सकता है यार is compressible. So all of the answer is the correct. The rise or the fall of head H is the capillary tube of the diameter d, liquid surface tension sigma, and the specific weight W is equal to 4 sigma 4 sigma by rho g d. Rho e yani W 4 sigma by rho g d. Here is the answer. Let's check the answer. Yes, here is the answer. 4 sigma by W d. Yeah, is the mission 4 sigma cos theta by rho g d. Cos theta is string. So here is the theta is the 0 degree. Sir, intensity inside the water droplets. It's where the sigma is the surface tension, d is the diameter of the bubble of the water droplets is the P equal to 4 sigma by d. C is the answer 4 sigma by d and 8 sigma by d 8 sigma by d for the soap bubble and 2 sigma by d by the for the water jet. Shear thickening fluid is also known as shear thickening fluid. This is the dilating fluid, the shear thickening fluid, and pseudoplastic fluid, the shear thinning fluid. The specific weight of the seawater is same as the pure water, less than the pure water, more than that of the pure water. Specific gravity is more than the pure water. As we know, the specific weights is the product of the density of the acceleration due to gravity. The density of the seawater more than the pure water, so the specific weight of the seawater is more than that of the pure water. Question number 71. What is the mass of the unit volume of the substance called? Mass per unit volume, this is called the density. Density equal to mass per volume. Question number 72. The unit of which the following properties is not meter square per second. Dynamic viscosity is not meter square per second, it is Pascal. Newton per meter square second. So C is the answer. There is the explanation. The thermal diffusivity is unit meter square per second. Kinematic viscosity also meter square per second. Dynamic viscosity Newton second per meter square. You can eliminate this option here also. Question number 73. The dimension of the coefficient of the dynamic viscosity. Dynamic viscosity is m l minus 1 t minus 1. D is the answer. Newtonian fluid rate shear stress is proportional to rate of shear strain. Rate of shear stress is proportional to coefficient of the dynamic viscosity. Shear stress is proportional to shear strain. Rate of shear stress is proportional to shear. Shear stress is proportional to rate of strain. So here is the answer. Can check that. A real fluid in which the shear stress is directly proportional to the velocity gradient. Newtonian fluid, like the real fluid, the water, oil, is the Newtonian fluid. Question number 75. When a fluid is at the rate, the shear stress is shear stress 0. zero shear stress for the rest condition of the fluid. Explanation: when a fluid at the rest, shear stress is zero. When fluid is at the rest, shear stress is zero. Du also zero. Change in velocity zero. So full time is zero. So shear stress is also zero. Thank you for watching video. Please subscribe and click click on the bell icon to get the new updated